So by the end of the previous video, I had hopefully convinced you of this second fundamental theorem of calculus. And that theorem was effectively that if you have a function that's going from a constant up to x, and when you take the derivative of that function, you're simply going to get the integrand with an x plugged in. And at the end of the other video, I had given one example sort of convincing you of this by taking that antiderivative and then just taking the derivative of it and showing you that they were the same thing. In the beginning of this video, I'd like to give a more theoretical perspective on that, and so I'm going to look at a crazier problem. So I'm going to begin by starting and saying, okay, there's a function f. This function is the integral from 5 to x of the function, let's say, well, I'll keep it simple, the natural log of t dt. Now, some of you are crying at home because you're like, wait a minute, he said he was going to keep it simple. This is natural. We don't even know how to do the integral of natural log. That's kind of the point. So don't be afraid. I'm doing this for a reason. So can we say what f of x is? By the way, just like yesterday, what I'd like to do is I'd like us to come up with a statement for what f prime of x is. Right? In particular, what I'd like to do is I'd like to convince you that f prime of x is just what I said it was going to be in the previous video. I'd like to convince you that it's going to be natural log x. And I believe that I can do that without you having any knowledge of how to actually do this. So check this out. Can we say what f of x is? And immediately you're saying, well, no, because I don't know how to do the integral of natural log t. That's true, you don't, but let's pretend that we knew. Let's pretend and just say, look, I have no idea what the integral of natural log is, so let's pretend that the integral of the natural log of something is a function called question mark. Because you're like, I have no idea what it is, let's just make up a function called question mark, right? So the integral of natural log is question mark, and then what would I need to do with these bounds? I'd have to plug in x and I'd have to plug in 5, right? So this will be question mark of x minus question mark of 5. And it's sort of at this point in the lesson where a lot of people just start to break down. In previous years, people get confused by this. So take your time. If you need to rewind and look at this again, all I'm saying is, out there in the wide world of math, somebody somewhere knows what the integral of natural log t is. I do. My second year students should. You guys will by the end of chapter 5. But the reality is right now I don't know, or you don't know, what the integral of natural log t is. So just pretend and just say, look, I don't know what it is. But whatever it is, I would plug in x first, and then I would plug in 5 next. So yay, this is a statement of what f of x is. And this is where the magic happens. What's the derivative of this? In other words, what's the derivative of question mark of x? Well, here's the exciting part. Question mark was the antiderivative of natural log, right? So the derivative of question mark should just go right back to natural log. So this is the natural log, but now it's the natural log of x because the function here was question mark of x. That explains why the t changes into an x. Now you may be wondering, wait a minute, but what about question mark of 5? Well, again, this is exciting. I don't know what the question mark function is, but what happens when I plug 5 into it? By virtue of the fact that it's a function, when you plug 5 into it, this is going to be a constant. And the derivative of that constant, just like any other constant, will be 0. And so at the end of the day, we end up finding out that f prime of x is the natural log of x, just like we expected. The whole idea is that because you're doing an antiderivative and then undoing that by taking the derivative, you're just going to get back the same function that you started with in the integrand replaced with an x. I hope that makes sense, because I'm really going to need to take that idea and sort of run with it a little bit further. So I want to go back to the beginning of this really quickly. This thing that I wrote down here, this is effectively the second fundamental theorem of calculus. It says if you have an integral that goes from a up to x, the derivative will just be the original function that was inside. I'm now going to write down a few variants on that because they don't always look like that. For instance, what happens if somebody says that f of x is the integral not from 1 to x, but the other way around, from x to 1 of some function like, let's say, the cosine cubed of t dt. What happens this time when I take f prime of x? What happens when I take the derivative? And so sort of like I did before, I'm going to start by telling you what the answer is. I'm going to tell you right now that when the bounds are written backward like this, when it's from a variable up to a constant, it's going to end up being the opposite of the function that was inside with x plugged in. Right? And this is probably something that should go in the notes. I'm really striving to help you guys understand where this comes from, but I understand that at the end of the day, you just need to know these. You just need to be able to do them. So let me sort of convince you of this, right? Let's follow the same process that we did last time, right? Can we say what f of x is here? Now I hope you recognize we can't do this integral right now. Like we don't have the tools to do this. You can't say, oh, I know the integral of cosine. That's sine. That's great. That's not cosine cubed. So because of that, I don't know what it is. So just like I did before, I'm going to say, look, I'm sure this thing has an antiderivative. I just don't know what it is. I'm going to call it question mark. So evaluating this is going to be question mark of 1 minus question mark of x. Note that here the 1 came first because it was on top. The x came second because it was on the bottom. Right? So now that I've done that, can we go back and say what f prime of x is? We certainly can, the same way I did on the previous problem. What is question mark of 1? I don't know. Because I don't know what this antiderivative was, I don't know what this is, but what I do know is that when I plug 1 into it, I will get a constant for this, and the derivative of that constant will be 0. So I have 0 minus. Now, what's the derivative of the question mark function? Well, question mark was the antiderivative of cosine cubed, so the derivative of question mark should take me back to cosine cubed with an x plugged in. And note that the thing that I get here is precisely what we said that it was going to be. So let me sort of show one of those. So one more example of that, just to sort of convince you of the idea that you've got it right. Suppose that you are given that g of x is the integral from x to 5 of the cosine of t squared minus 3t dt. And then you're asked to find g prime of x. And if you're watching this at home, I'd recommend you pause for a second and see if you can figure out what that thing is. If you understood the previous example, it should be really easy. And to be honest, it shouldn't even take in any work from you. Okay, so because we notice that the x is on the bottom this time and the 5 is on the top, we know that g prime of x, taking the derivative of this antiderivative, is just going to net me this inside function, but because the x is on the bottom, the sign will change. This will be negative cosine of x squared plus 3x. And we're done. There is one more level of complexity that these problems can go up. It doesn't get asked very often, but I'm a fan of the problems. Rather than try and tack that on here, I'm going to add that in the next video.